Good morning to one and all. Welcome to JCE Connect. This is Professor Vinayak Nannoji from Jain College of Engineering, Belagavi. So we are into module number 4 and we are discussing joining processes, that is soldering, brazing and welding. So in the last session we have studied about arc welding. So today we shall see the different arc welding electrodes. So we have studied already about arc welding. So in arc welding we have used electrodes. So these are of different types. So we shall see what are those and how exactly they are classified. So there are actually two types of electrodes used in arc welding. The first one is called as the consumable electrode. So as the name itself suggests, consumable electrode means it gets consumed while welding process. So consumable electrodes usually melt along with the workpiece and fill the joint. So as you remember that we do edge preparation and whatever gap is being maintained, so there the consumable electrode will be melting and then it gets deposited in that area. So they are made up of various metals depending upon their purpose and also the chemical composition of the parent material. So parent materials are nothing but the components which you are going to weld. So depending upon what type of material you are going to weld, accordingly we select the consumable electrode, because the parent material and the electrode material has to be similar. Similar in the sense it should have some similarities. So the consumable electrodes will be either bare or it will be coated electrodes. So when we are using a bare electrodes, the globules of the molten metal while passing from the electrode absorbs the atmospheric air, that is nothing but oxygen and nitrogen, and it forms non-metallic constituents and which gets entrapped in the solidifying weld metal, and it thereby decreases the strength of the joint. So as you have studied already that when we are using an electrode, so the molten metal will be in the form of a pool, and if it comes in contact with the atmospheric air, then it is going to react with the oxygen and then oxides are formed, which will usually reduce the strength of the joint or strength of the material. And coming back to the coated electrodes, so the coated electrodes usually facilitates the protection of the molten metal from oxygen and nitrogen, and it provides a gaseous shield around the arc and the molten metal, and it also establishes and maintain the arc throughout the welding. So the arc will not vary. It will be having a constant what you can say, a constant arc will be maintained by using consumable electrodes. And these consumable electrodes also facilitates the formation of slag over the joint, thus it will protect from the rapid cooling. So usually we do not suggest or we do not allow the weld to go for a rapid cooling, because when there is a rapid cooling, then the material becomes very hard and brittle, and due to which the strength of the weld metal will be not good, or it will reduce the strength of it, which is not required. And hence these electrodes or the consumable electrodes which are coated will protect the rapid cooling by formation of slag. So this slag is again chipped off later on before we allow it to cool down. And the coating is usually composed, that is the coating electrodes are usually composed of chalk, ferromanganese, starch, kaolin, and alloying and binding materials. So these materials will form the slag and also the gaseous shield around the molten pool. Then coming to the second one, that is non-consumable electrodes. So non-consumable electrodes are used and also in addition we require filler materials. So the advantage of using a non-consumable type electrode is that the amount of metal deposited by the filler rod can be controlled, which is not possible in other type of electrodes. So the next one is we shall see the general welding procedure. So we have different steps to be followed so that we'll have a sound welding. So here we are going to study the step-by-step procedure for welding, and it is as shown in the below steps. The step one is the cleaning process. So in cleaning process, the surface of the parts to be welded are cleaned thoroughly for removal of any dirt, oil, grease, etc. So this is a very important step before starting with any welding process. This is the step which actually we follow, that is cleaning, and cleaning or removal of any type of grease, dust, dirt, or any other foreign material which is not required for us. The next important step is step number 2, that is called as the edge preparation. So the process of preparing contour at the edges of the pieces which are to be joined is called the edge preparation. So this involves beveling or grooving or chamfering, we can say. And the idea behind this is to get fusion or penetration through the entire thickness of the member. So the edge preparation is necessary mainly for butt welding of thickness which are greater than 3 mm. So the various types of edge preparations which are required for the butt joints are shown in the below figure. So here you can see that when there is a material which is to be welded and the thickness of it is more than or up to 8 mm, then we have something called as a square butt joint. Here we do not maintain any or prepare any edges, but we maintain a distance of 1.5 to 3 mm. That is the figure number A. And then in figure B we can see that if the thickness is up to 6 to 18 mm, with the thickness of the component to be welded is up to 18 mm, then we have a chamfer which is about 60 degrees, and then you can see the gap between the two joints is about 5 mm. So this is called as the single V butt joint. Then in figure C you can see that if the thickness is 10 to 25 mm, means what? If the thickness of the component to be welded is up to 25 mm, then we go for something called as a single U butt joint. So in this you can see that the gap is up to 5 mm, and then you have a U joint. We prepare a U so that the weld material can be deposited and which will make the component strong. Then in figure D, when the thickness of the component is greater than 16 mm, then again we have something called as a double V butt joint. So in figure B you can see it is a single V wherein the angle is 60 degrees. So here also the angle is 60 degrees, but the angle is on both the sides, and the thickness or sorry, the gap between the two components is about 3 to 6 mm. And then the last one is called as double U butt joint, as the name itself suggests. So double U means the U formation is for both above and below. So these are used when we have the component thickness more than 20 mm. So 45 degrees U joints are prepared, and the thickness, sorry, the gap is maintained for about 4.5 mm. Then we shall see the step number 3. So in step number 3, so we have in step 1 we have cleaned the components, and in step 2 we have prepared the edges. So once we have done with step 1 and step 2, the third step is to clamp it. Clamp it in the sense we have to use some suitable jigs and fixtures so that we can hold the components which are to be welded. So these jigs and fixtures are used so that there are no undesirable movements during the welding process. So whenever we are starting with the welding process, so the component should not move from its place. So for that reason we have to clamp it properly. So that is done in step number 3. Step number 4 is checking for the safety equipments. So in safety equipment such as personal protective equipments like goggles and shields to protect the eyes, and then we have protective clothing to prevent any spark or molten metal flying, and then we have safety shoes, then we have gloves, aprons, and other safety equipments must be ensured. That is step number 4. In step number 5, so we do the initial weld. So initial welding is it is also called as the tack welds, TACK tack. So these are done at the opposite corners of the joints to secure the pieces together. So any cracks at this edge must be chipped off using a chipping hammer, as these presence of cracks cause residual stresses. So the length and spacing of the tack welds varies with the thickness of the metal and the length of the joint. So the tack weld thickness and the spacing will be depending upon the length of the joint and thickness. Then comes step number 6, which is called as the intermediate and final welding. So once we are done with the tack weld, so the process of welding can be started. So we have secured the components by doing tack welding. Means what? It is not going to move from its place now. And now we can start with the welding process. So the weld joint is formed through various weaving movements. It depends upon the thickness again, and the various shapes called weld beads are used. So during this process the filler material and suitable flux is used. So after the intermediate run we go for the final run. And the last one is called as the excess material removal. So after the welding is completed, so before it starts cooling down, so before the component which is being welded starts cooling, we have to chip off the excess material. So this excess material is chipped off using tongs or chipping hammers, so that any excess material will not get entrapped inside or above the material. So that has to be removed by using these tools, which are called as tongs and chippers. Thank you.